Uh, very, very good evening to everyone. Okay, so let's continue further on. And now we're going to take up the next topic, which is kinetic energy of translation plus rotation. Right. So now let's take a case where you have an object and it is nothing but translating over here. Right. So when we say it is translating, every point has the same velocity at any instant of time. Right. So therefore over here, in this way the object is, in this way this is the translating object over here, right? Now what if an object, instead of translating, is simply rotating over here, right? Let's say that this is the axis, right? The angular velocity is nothing but equal to omega this way, right? So what if we were to combine these two motions? You can think of this in this way, that there is the fan which is rotating, right? And what if this fan was fixed to the ceiling of an aeroplane which is translating? So that fan is rotating about its center, and that center is translating. So you have a rigid body which is translating plus rotating, right? So it is nothing but a case where the center of mass has a velocity, and over here the other particles are rotating, uh, maybe about the center of mass, maybe about some other axis over here, right? So therefore this is the situation, right? So therefore over here, what can we write this as? What is the kinetic energy of a body which is in pure translation? Half mass of the rigid body times v square. And what is the kinetic energy of a body which is in rotation? There is nothing but we have seen in the previous lecture. It is half I omega square, right? And if we were to perform both of these functions together, then the kinetic energy, being a scalar quantity, will simply add over here, right? So therefore the kinetic energy of any object which is in translation and in rotation is nothing but given as a sum of half mv square, where v is the velocity of the center of mass, plus half I omega square, where I is the moment of inertia about the center of mass. Right? Okay, so now let us let's take some examples over here. Right? Suppose that suppose that we have an object which is, let's say it is rolling. Right? Now, what is the meaning of rolling? You cannot roll actually. Actually, you can if you do some acrobats, then probably yes. But normally, circular boundary objects are the ones that will roll. So this is nothing but the velocity over here. This is center of mass. This is the angular velocity over here, omega. And whatever is the velocity of this particular point of the ground, that's called the G point. If that is the same as the velocity of this point called the P point, it means that they are not slipping against each other. We say that there is no slip. Fine. So therefore, we say that such motion